Hi, today we are going to talk about two-dimensional algebraic vector operations. So remember, two dimensions, it just goes right, left, up, down. We don't have a third dimension. And we're going to talk about adding, subtracting, and doing scalar multiplication with those. All right, so if you remember before when we talked about vectors, when we did the hard stuff, right now this is going to be a little bit easier, which will be a nice break. It has a direction in degrees. It also has a magnitude, which is a length. So we've talked about that before. We're still going to talk about magnitude, but we're going to do it in a little bit different way. Also, we're going to talk about direction in a little bit different way as well. We're going to talk about it more in terms of adding and subtracting vectors and finding out where they end up. Okay, so here's kind of a fancy rule here, but this just says, so if you have a point, and that's the starting point of the vector and the final point of the vector, so a start and an end, terminal is just n, you can rename it as an ordered pair by subtracting the x's and subtracting the y's. Okay, and the order there matters. It has to be the second point minus the first point. You can also find magnitude by doing the distance formula. If you remember before when we had a right triangle, finding the magnitude, we used Pythagorean theorem. Well, distance formula is just a variation of Pythagorean theorem. Okay, so if I have 2 points, so let's say I'm at 1, 3, which is right here, and I end up at 3, 6. 1, 2, 3, 4, 5, 6. So I have this vector here. So I'm going to find the ordered pair. So I'm going to rename this as 1 point by subtracting the terminal side. So I have to go the second point minus the first. P is the ending point. Okay, it goes from M to P. So I'm going to go 3 minus 1, and then I'm going to go 6 minus, I said 6, then I wrote a 3. 6 minus 3, and we end up with 2, 3 for an ordered pair. So what that means is renaming that as an ordered pair. If I go right 2 up 3, if I start at 0, 0 and end up at 2, 3, you can see that vector looks exactly the same. We just repositioned it. So it has the same direction, it has the same length or magnitude, we've just repositioned it. So this is the ordered pair. And if we do magnitude, we're doing Pythagorean theorem. So again, I subtract the x's, I subtract the y's. 3 minus 2 is 2 squared, which is 4. 6 minus 3 is 3 squared, which is 9. And I end up with square root of 13, which is 3.6. So both of these, of course, have a magnitude of 3.6. Whether you're at the first point or the second point. And we're also going to talk about, just in a few minutes here, if we're just given the ordered pair, how we can find the magnitude as well. Okay. Let's look at another one. This one starts at -1, -4. It ends at right 2 up 5. So this is what it looks like. By the way, I guess I should put this as the magnitude, just so we don't forget. So we'll go ordered pair. We're going to second minus first, 2 minus -1. Second minus first, 5 minus -4. And then we end up with 3, 9. So the magnitude, so kind of notice what happens, because this is going to help us later, is when I do 2 minus 1, I I already know I'm going to end up with 3 squared. 5 minus 4, I'm going to end up with 9 squared, which is 9 plus 81, which is 90. And square root of 90 gives us a magnitude of 9.5. So again, kind of recognize really what we're doing is once we have the ordered pair, I can just square that, and add them together. Right? So that's just kind of remembering that is going to make more sense when we are just given an ordered pair. Okay, so the length of that green arrow though is 9.5. Well, if I start at 0, 0 and I go up 3, up 9, that vector should look like it has the same length and it's going the same direction. Okay, so that's how you find, you rename a vector that starts one place, ends another as one ordered pair with the assumption it starts at 0, 0. And magnitude is just the distance formula. Okay, so we're going to add, subtract vectors, and adding and subtracting vectors are, remember before we put two vectors together and we used law of sines, law of cosines to figure out the direction and the magnitude. Well, now we're going to put two vectors together and just name it as one ordered point. So here you can see we're just, adding the x's, adding the y's. We're subtracting the x's, subtracting the y's. Here with scalar multiplication, it's almost like the distributive property. I'll show you what we mean here. Oops. Just give me a chance to quick erase this. I was working on it before. Okay. So m plus p. M plus P. So what we're going to do is we're just going to take the x's and m added to the x of the p, and then we're going to do the same with the y's. Negative 6 plus 4. So we end up with 3, negative 2. Okay? So just kind of to show you what that looks like. Maybe I'll put it here. So if I have 5, negative 6, write 5 down 6. So we have this vector. And we're putting it together with negative 2, 4. Negative 2, 4. Okay, so remember before we would make a parallelogram and give it a point over? Well, I can find the resultant vector by renaming it as a point. If I go right 3 down 2, 1, 2, 3 down 2, that's the resultant vector added together. So you can see this is kind of a little bit squish looking with the vectors, but if you can see that if I were to make parallel lines to the green and blue and then start at the beginning and draw that diagonal like I did before when I used law of cosines and draw the resultant vector, well, now this is the ordered point that they add up at, or they end up at. So it's just a different way of kind of showing direction and magnitude, and it's a much easier way. Okay, this is if we were going to take a vector and make it 6 times as long. So this is pretty straightforward as well. We just distribute. So I would go 6 times 0 and 6 times 5. All right, so the initial vector, which was 0, 5, 1, 2, 3, 4, 5, if we make that 6 times as long, it's going to end up at, well, something way up there. I don't have room for it, but it would end up at 0, 30. Okay, m minus n. So we should be able to pull it up so we can see the vectors there. Okay, so this is m, and this is n. So I'm going to go 5 minus 0. So I have to do it in that order. 5 minus 0, negative 6 minus 5. And I end up with 5, negative 11. Okay, so when we subtract, we just have to be careful that we do it in that correct order. And for this one, I think I will, just so I can put it all on one line, do it down here. So 3m, so I'm going to go 3m. My m is 5 times negative 6, 4 times n, minus p. So just like order of operations, we want to do multiplication division before we add and subtract. So we're going to do this scalar multiplication, which is really distributing. 3 times 5, 3 times negative 6, 4 times 0, 4 times 5, and then the p stays the same. And then finally, we're going to add and subtract. So I'm going to add and subtract all the x's. 15 plus 0 minus negative 2. And if we do the y's, negative 18 plus 20 minus 4. And this becomes 17, and negative 18 plus 20 is 2, minus 4 is negative 2. Okay, so that's a bunch of, we're making vectors 3 times as long, 4 times as long. We're putting them together and subtracting them. So what subtracting really means is we're doing a vector in the opposite direction. Okay, when we subtract, it's just taking that original vector and we're turning it around in the other direction. But otherwise, it's we're just putting that together with the others. So now we've got 3 vectors, 3 forces, and the result of it is this. It's starting at 0, it'd end up right 17 down 2. Okay, so one last thing here, and that is unit vectors. So you can imagine that if, again, if we're looking at a graph, 0, 1 just looks like this. So I represents that little unit vector 1, 0. I'm sorry, that's J, 0, 1. This is 1, 0, right? This is right 1 of 0, so that's your I. So that's what a unit vector is. So if we're going to find the magnitude of a vector, this is kind of a little something new, but remember before I talked about that when we subtract 2 vectors, we get one ordered pair. So when we reposition it to 0, 0, we get a new ordered pair. Well, really, when we subtract it, we just end up with 1x, and then we square it. When we subtract it, finding the magnitude, we subtract it, we get 1 y value and square it. So this has already been repositioned to 0, 0. So we don't have to subtract 2. We just take the x value and we square it. We take the y value and we square it. So this becomes 124 plus 25, which has a magnitude of 13. Okay? So that's one thing. That's still magnitude, but it's just given 1 point, assuming the initial point is 0, 0. This is what this sum of unit vectors is. It's just a different way of writing a point. So if I know I go right 12 up 5, I can also say that as 12 of these, right? 12 of these here, I go right 12 of those units, and then I go up 5 of these units. So it's just a different way of writing an ordered pair. We'll just do a couple others. So magnitude is I take my x value and square it. I take my y value and square it. And then we take this square root. So it is 1 plus 16. And the square root of 17 is about 4.1. So that's the magnitude. When I write it as the sum of unit vectors, this is all I'm doing. I'm doing -1, so I'm going one of these units to the left, and then 4 of those units up. Keep getting my I's and my J's mixed up. Okay? So, I mean, we can do one more, but I think we're probably good with that. So that is 2-dimensional. The next lesson is going to be 3-dimensional. Okay, subtracting vectors. So we're just going in order. So this is 5. Here, I'm just going to write this out, I think this time. 5 minus 6, or -6 minus -2, 4. Okay, so we have to do this in order. So I'm going to put a minus. So I'm going 5 minus -2, -6 minus 4. And it's 7, -10. Okay? And finally, if we're doing a bunch of those, I'm going to basically a combination. By bunch, I mean we're multiplying and then we're adding and subtracting. Well, first we're going to do like the 3 times m. So 3 times m is 5, -6 is equal to 15, -18. Okay? So that's that 3m. You know, I'm going to scoot it down a little bit so we can see the whole thing, because I wouldn't normally do it in pieces like that. I just kind of ran out of room. So 3, 5, -6, plus 4, and n is 0.5, minus p. And p is -2.4. Okay, so now we can just see it a little bit better. So this, like we were saying before, becomes 15, -18. We just distribute that 3. If we distribute the 4, 4 times 0, 4 times 5, and then we just rewrite the last one. And finally, now we're going to go for our first point, 15 plus 0 minus -2. For the second point, the y, not the point, second value, the y, it's -18 plus 20 minus 4. And we end up with, that's plus 2, so that's 17. -18 plus 20 is 2, minus 4 is -2. Make that the same color, I guess. All right.